.NET 6 IoT on Linux with Chris Tacke.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host, for helping you and your teams move fast, deliver quality, and run your software with confidence in Azure, all while using everything the .NET ecosystem has to offer. And this podcast is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results. They are hiring, by the way, architects and .NET engineers who'd like a path to become an architect. So you can go to clearmeasure.com/careers for that. And finally, be on the lookout for the new video shows announcing pretty soon. So the guest on the show today, I'm excited to have Chris Tacke. He is an industry leader in managed application development for industrial process control, medical, telematics, and just about any other embedded industry. And his specialties include mobile and embedded device application development, specializing in Windows, CE, and the .NET Compact framework. Chris, how are you, sir? Welcome to the show.
Thank you. Doing well.
Awesome.
Thanks for having me.
Absolutely. Yeah. And for those who have been paying attention to the Wilderness Labs Dev Camp, you'll recognize his name on there. But for those who maybe haven't seen what you're doing there at Wilderness Labs or heard any of your other talks, I'm always curious with people who've accomplished so much as you. What are the key points in your background that kind of led you up to what you're working on today?
Oh boy, that's a fun one. Most people are a little surprised to hear my background. I actually got a degree in geology long ago.
Oh, nice.
And so my first job out of that, we were doing seismic work and basically taking in a whole ton of data, 2048 samples per second on 4 channels and hand analyzing it. And it was not long before I decided that I needed to write something that would do that for me. And so really my first foray into programming, I guess, as a job was in Excel, writing VB macros to analyze the data. I've been playing with computers since, the days of the VIC-20 when I got one, probably when I was about 8 years old. But it never really occurred to me that you could use it as a career. So I was always chasing something else. So I think that was probably the start of it. And then I went into actually software development, I don't know, probably about 5 years after that. I was taking a class just for interest. How do I do better? Basically, I'd reached the limit that I could with a VB macro. And so it's like, I wonder how I could do better with this. And somebody, came into the class and was like, hey, who's looking for a job? I'm like, well, I'm not really. But then they told me what I would make. And then I said, well, maybe I'm looking for a job.
Just what I was looking for.
And so that got me into actual professional development. And then during the .com boom, I went to it was actually a horse race in Virginia. And we were at the Microsoft booth. So they had a sponsored booth there. Mm-hmm. And another company came by and they were looking for mobile developers. And at the time, there was no real mobile development. And they did a broad swath of everything. So Palm, RIM or BlackBerry, as well as Pocket PC and HPC and things like that.
Handspring visors, I'm sure.
Yes, absolutely. And so I was like, oh yeah, I'm interested. I don't know anything about it, but what the heck? I'm willing to try.
Yeah.
So I went and worked for them until the .com, crash. When it got to the point that it was me and 4 managers, I thought maybe it was probably time to go elsewhere. And then I moved from there to actually a company that made single board computers and then did the OSs for them. And we did Linux and Windows CE. And I was the Windows CE. I started out as the product manager and then moved over to the, I guess, engineering manager for the Windows CE side of things. And then worked there for about 4 years. And then during that time, helped found OpenNetCF. So anybody that did work with the Compact framework would be familiar with that. Did a lot of work with Microsoft, writing for MSDN and doing, trade show talks, things like that. And then I hung out my own shingle and did independent work for, 20 some years. And then about 2 years ago, I decided I'd, join an actual company again. So I actually joined a company called Hypergiant. A friend of mine was working there and they were talking about doing space-related things. So how can you not say yes to, doing stuff in space? So I said, oh, absolutely, I'll come work for you. And it was actually a little bit before that Wilderness Labs came on my radar. I found them. I honestly don't even remember how I found them, but I sent them just a cold email and said, I'd really like to work on this, and I think you'd really like me to work on it.
Yeah.
And it was funny, and Brian was like, oh, sure, absolutely. We'd love for you to come work for on this. And, well, I ended up being the owner of the Meadow Core pieces. So I do a fair bit of the driver development. So Meadow has NutX, which is it's a POSIX OS running on it. It's an RTOS, so it's not a full up OS. So I do the drivers in it that talk up to managed or that managed talks down to. So that interface layer between the two. Mm-hmm. So how does Meadow, turn on the GPIO or talk to the I2C bus or things like that? So I own that. And then about a year ago, I was working on other things for my day job. And I'm like, man, I really need this stuff to work in Linux. I'm like, I need to talk to these peripherals. I need to talk to, GPIOs. And we've got this huge library of things in Meadow Foundation. And I'm like, I need one of those sensors. I need one of those sensors. And I looked at the .NET stuff from Microsoft, mm-hmm. The .NET IoT library, and they were kind of disjointed and they were different in how each of them worked. And I'm like, I can't get my brain around some of these. I'm like, all of these are supported by Meadow Foundation. I wonder how hard it would be for me to make this port to Linux. And so I ported to Linux, started out with the Raspberry Pi, but I've since moved on to like the NVIDIA Jetson series. So I've done both the Nano and right now I'm working on the AGX. And in fact, today I did a new driver for a peripheral, and the first place I did it was on Linux on a Jetson Xavier rather than even on the Meadow. But I know it will run on the Meadow as soon as it was working here because of that platform. I guess it's like a hardware abstraction layer, but it's more of a OS abstraction layer.
Now, I'm not familiar with the Jetson under the Raspberry Pi, but how does that compare? The Jetson?
It's like a Raspberry Pi on steroids. If you go to like the Jetson Nano, it's an ARM-based device, but then it's got a GPU. Okay. And then the Xavier, which I'm using, I think it's got, I'd have to go back and look, but it's something like 1,024 GPU cores. Mm-hmm. I mean,
wow.
Wow. Yeah, it's a monster for power, but it only uses about I guess it's got different power levels that you can turn on or, you can scale it up or down. In the most extreme use, I think it's 20 watts. And that's using, 4 cores of processor and 1,000 GPU cores.
So that could still run in the middle of nowhere with a solar panel and a car battery.
Yeah, I run them off of, rechargeable batteries. That's what I have on my Rover here. Mm-hmm. And so you can do all of that. So you've got sensor access, but you've got all those GPU cores and they're designed for being able to run ML models and things like that, right? So you can run TensorFlow and all of that goodness as well.
Right. Well, let's talk about, why should the .NET developer even care? The regular, .NET application developer, they host some stuff in Azure, they've got some stuff, here and there. And with Raspberry Pi and even the Meadow boards now, looks like a stick of gum. You can kind of run them anywhere. And historically, .NET development on bespoke chips and system on a chip hasn't been easy, hasn't been consistent. It's all over the place. And even Microsoft's Azure Sphere, it's like, oh, well, forget about .NET, write it in C, And so for all the people who are, okay, I'm writing .NET applications normally, but then I need to integrate with something that, oh man, wouldn't it be nice if it was just out in the field, feed me back some data? But there's this wall where we just can't quite get there, and we're in a whole nother world. So does this bridge that gap now? I'm jumping forward. With .NET 6 on Linux and getting Meta to work on it, what's the vision?
Sure. And so this is, just as you described it, it's been a problem for 2 decades easily, right? We had Windows CE, and that was like, oh, it's great. It was a great operating system. It had real-time capabilities. But if you were a managed code developer, initially you had no option. There was like a Visual Basic 6 toolkit thing that was pretty abhorrent. And then they came out with the .NET Compact framework, which was just a scaled down subset, but it was a complete fork. And actually, I don't even know if it was a fork or if it was a build from the ground up of .NET. So as .NET evolved, the Compact framework didn't, right? You didn't get all of the new features. And so if you were a .NET developer, it's like, oh, I've got all these new features that I can use on the desktop, but I can't use them on mobile. I can't use them on embedded. And then, Windows CE kind of, drove off into nowhere land, wherever it is now. And Microsoft kind of abandoned it. And then we had Mono for a while, and Xamarin was, doing Mono work, but that was mostly mobile. It was how do we get it on a handheld? Yeah. There was very little thought to how do I get this on an embedded device that's talking to sensors? As a .NET developer, you go, okay, well, I have all of these skills in this great language, and I've got all of this, years of experience and work that I've done, and I've got all these assets that I've written and tools. How do I bring those to doing something like this? A lot of developers are interested in how do I turn on and off an LED? How do I deal with switches? And if you're a .NET developer, you don't really want to go down to like an Arduino and write C and deal with like the IDEs that a lot of embedded stuff is. The IDEs are horrible. I mean, let's just call a spade a spade. They're terrible.
It might as well be Notepad, right?
Yeah, nobody wants to use those, especially if you're coming from Visual Studio, right? Yeah. I'd love to use the tools that I know, the languages that I know. I don't want to have to context switch between, is this C or is this, you don't want to have to deal with that. So what we've done is from the perspective of development at Wilderness is to say, let's take your skills, directly bring them in. We're not going to try to, have some subset. We're not going to have this branch of .NET that feels .NET-ish. Who wants to still use array lists when we've got, async, right? You don't want to have to be penned in. So we're like, okay, well, how do we just use the entire range of .NET skills, but allow you to talk to hardware? And so that was one of the first goals, was to run on modern .NET. But then the second goal, which is also challenging, is a lot of guys go, okay, well, I write desktop apps and I write server apps. I don't really know what an interrupt is. I may have heard the term, but it's kind of nebulous. What is an interrupt? And, registers and opening up a data sheet for a part, that can be daunting and it can be a little confusing, especially if you're not used to it. So what we said is, well, how about if we take all of those and wrap an API that makes sense around it, right? That feels .NET-ish. Just because a serial port's been done the same way since 1970 doesn't mean we have to continue to do that. If the object model was bad, let's address it now. And so we've gone through and we say, there are all these peripherals that you can buy for Raspberry Pis and Arduinos and stuff. Let's just start integrating all of those and then, open that up so that developers can go, oh, well, I know .NET and I have this idea for a thing that I want to build. Who knows what it is, a weather station, or, I'm just clicking a button and doing something. That is of interest. Well, I can go buy for, $5, $10 at the most, all of these little components that I can stick together. And, if I can run a breadboard, there should be no reason that those developers can't sit down and make something, interact with your environment through hardware, which is, it's a lot of fun. And it's a different, mental model that you normally have from desktop or server development. There are still things that you have to keep in mind. We don't have all of the memory and processor and all of that you would have in those cases. So there are some things that you have to, be cognizant of, building objects and things like that. But generally speaking, if you can develop for the desktop, if you can develop for a server, you can now develop embedded stuff without any problem. 5 minutes of tinkering around, getting it hooked up to your tool set, and then you're away and running.
Mm-hmm. Now, the current Meadow board does all that.
Mm-hmm. Yes.
What I'm wondering is, okay, what's the vision now to say, okay, we need to do this for Linux?
Right. Well, there are a variety of reasons. Number one is a ton of people have Raspberry Pis. They've got these pieces of hardware laying around. I probably have 20 Raspberry Pis in the drawers behind me. So the availability of these things is first. Second, if you go, okay, well, I have this idea for a solution, but I don't know what kind of scale for processing power or memory I might need, right? So you can write it on the Meadow and go, I'm starting to run at the ragged edge. I'm running out of resources. How do I move to something that has more processing power or more memory? Well, it'd be nice to be able to do that with just take my code, pick it up, move it over to another project, drop it down, and then everything works. Yeah, maybe I have to say, oh, now it's on pin 1 and 5 instead of 2 and 8. You have to do a couple of mapping things like that, but otherwise it just works, right? Same thing, you go, oh, well, I think it's going to need a bunch of stuff and I'm going to try it on a Raspberry Pi. And then after you get your solution, you go, boy, I don't really need this much memory. I wonder if I can get by with less power, right? I want to run this on a battery out in a field that just turns on once a day.
Yeah, like a watch battery.
Right. In that case, a Raspberry Pi actually uses quite a bit of power. And so you go, well, I'd like it to, just sip on that battery or use a little solar panel to control it. Well, you can develop it for that Pi and then it will scale down. And then, like I'm doing with these Jetsons, you go, boy, I'd like to bring in this sensor data and bring it into a Docker container. And then I have another Docker container that I'm running an ML model that's doing all kinds of crazy, like vision or whatever. You can have it, talk to one another all on the same thing. Just bring your code without changing anything. So that really was, for me, why I wrote the Meadow Linux stuff and continuing to drive it forward. It's because I want to be able to bring in data from sensors on any device and be able to go, oh, I'm going to try it on this device, or I'm going to try it on this device. And I can change from a Meadow F7 all the way up to a Jetson class without changing anything at all, other than about 2 or 3 definitions. And that's just because the pins are different in different locations on these devices.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast,
delivering quality and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
So let me see if I can summarize, and you tell me where I'm getting it wrong. So
Sure.
you got the Meadow F7, and
Yep.
I can write C#, .NET, use the regular .NET 6, .NET standard libraries that are out there from NuGet, but I've got to run it on the F7 board. And I can't just, without this new thing, I can't just do the same stuff, take the same code and run it on a Raspberry Pi without some type of change, right?
Correct.
Okay.
Because the original Meadow stuff was, fairly tightly coupled to the F7 board because that's what we were all using internally. And I said, well, we have this huge library set and we had it fairly well architected that there was a core and we had some interfaces and things like that, but it was still designed for the embedded F7. And we're probably going to do an STM32 as well. But I said, well, really what I want to do is split this. Can I take all of the definitions of, what a I2C bus, an SPI bus, and the digital outputs, take all of that and separate it from the platform it's actually running on, and then write that shim layer that would run on Linux that can talk to the Linux drivers to then communicate with the digital I/O, the A to Ds, I2C, SPI, all of that kind of stuff.
So hopefully coming out this year, Maui is aimed at writing .NET 6 on any mobile device, kind of like the write once, run anywhere on handheld mobile. Don't let me put words in your mouth. Is this the same vision? Write once, run anywhere embedded?
I would say as close to that as you can. I believe that it's never going to be 100% possible simply because of, like I was saying, the physical pins on these devices are in different locations and they have different addresses. So you can't just write once, run anywhere, though you can very early on in the boot up of your device say, what am I running on? And then use a definition. So if you know at compile time all of the breadth of the devices you might run on, you can do a switch, or an if then, and say, if I'm running on a Raspberry Pi, use this definition, but if I'm running on an F7, use this. Once you've done that, then all of the code just works.
Nice. Okay. And this is any Linux distro, right?
Yes.
Okay. So Raspberry Pi, it's got their Raspbian or whatever people use. So now,
in theory, right?
Sure.
So
in theory,
it's just me doing it. So what I have tested is I've done it on Raspbian. I've done it on CentOS. I've done it on Ubuntu, and I've done Alpine. And I know it works on all of those. A lot of it because I work in Docker containers on the Jetsons. It gives me the ability to kind of quickly change which distro I'm working on. And largely, I've not seen any issues at all. Okay.
Now, the DevOps process and environments that are necessary for server applications, very different than what is necessary for an embedded pipeline, especially if you support a handful of different embedded chips and whatnot. How have you already seen how this impacts just the process of building test suites, promoting a release candidate, and then having, various test environments all the way to the point you say, okay, this is GA, go with it?
Yes. In fact, I think testing right now, the surface area of all of the Meadow stuff that we have at Wilderness has now gotten to the point that it's very difficult for us to, get our hands around and make sure we're not regressing and that everything is good. And in fact, we've got another open source project called Meadow Test Suite that the goal behind it, and it's another one that I've been building, is to be able to deploy applications or binaries. It's its own application, deploy assemblies down to a device then that application uses reflection and finds tests that look just like an xUnit test that can then talk to hardware. So our goal is to have a rack of these in each of our offices so that we, from our desktop, can do development and then push. And when we push to the GitHub repo, we'll have some device, probably like a Raspberry Pi, watching. It'll go grab the binaries, pull it down, and communicate with the hardware and turn on a green or a red LED on the wall. And we'll go, oh, we have a failure somewhere. I need to go look at this.
Raspberry Pi build server.
Yeah, absolutely. That's what I fully intend to do that.
Nice.
We'll have our test servers running on things like Raspberry Pis.
Okay, so with the Meadow OS just on the F7, even just to kind of run your code in the developer loop, you had to have that Meadow board connected to your Windows PC, right?
Yes.
Does this open up opportunities to do some testing in Windows subsystem for Linux? Or is it always going to require some type of device connected to the development machine for that inner development loop?
So you're a man after my own heart. So I've been noodling through this myself, right? So there are a couple of ways that I think I could attack this. There is a chipset that I have laying around here somewhere that I can attach to USB that gives me GPIO and things like that. And I think it also gives me I2C. So I could plug that into USB and then either Windows, so then it's not even Meadow Linux, then it's Meadow everywhere.
So it's kind of like a PC hat, a USB hat.
It is. So that is one option. The other option would be to write some sort of like an emulation layer, maybe just an application that, has an API that behaves the same way as well. There are a few different ways to attack it, and I would love to do it. I haven't had time, right? I got 50 million plates I'm already spinning.
Right.
So I keep going, this is one I want to do. When Meadow Linux gets a little bit more, robust, I think I will probably attack that because it's a fun problem and it will make DevOps easier, right?
Yeah.
Because right now, I can't have a GitHub action build and then test my app, right? Because GitHub doesn't have an F7 up there for me to deploy to.
Right.
So if I had something else that at least simulated the behavior, assuming that my simulator doesn't have bugs in it, because I don't write code with bugs, but assuming that it's okay, then that would allow us, first pass on a lot of those types of things to feel confident about it, right? The challenge is, how much do you simulate? If you're simulating all the way down to like an I2C bus, well, do I simulate the turning on and off of the bus lines? You could argue that that's a good thing to do.
But it could be where the problem
sounds
lies.
like a lot of work.
Yeah. Well, you can have a bug anywhere. It could be.
Yeah, absolutely.
The bug might not be in your C#.
Exactly.
So, okay. Well, this is fascinating. This problem still exists out there where, even with the Windows IoT operating system and all of the embedded stuff we have now, you have to have a totally different environment depending on what you're targeting. Whereas this, you're actually creating the new, it's still .NET framework, but you're creating this new shim, this new thing that actually makes it where we care less about the differences of the system on a chip.
Right. And that's my goal, right? That is really, I'd like to, when I sit down and I start writing the code, beyond that first initializing the hardware thing, once I've done that, I don't want to think or even care about what I'm running on. I just want to say, hey, go get the temperature from that sensor. Mm-hmm. Have I tilted 45 degrees to the left?
Yeah.
I don't care what's telling me. I just want to know that information.
Right.
And this is a good drive toward that goal.
Yeah, man. And if you can have the F7s and the Raspberry Pis and the Jetsons, then I can imagine the Intel NUC devices and all these other puck-sized full PCs. All it takes is for people to say, hey, well, let me create the docking station for GPIO and all these different things. And now, yeah, you've got all kinds of miniature computers that do have plenty of power out there in the field.
Absolutely. Yeah, I've got some Intel NUCs here, and it's also on my goal. That is the one that I was talking about, that USB thing that's a bridge to I2C. That was my target that I wanted to run it on, is the NUC, because it's like, oh, if I can run it on anything small that people go, oh, you can't do that. To me, I'm like, oh, that's what I want to try to run it on.
Yeah.
It's got to work there.
Right.
Yeah. Yeah, well, it'll be fantastic. I mean, as a .NET developer, the ability to go do these things, this is no longer the domain of, the specialty C developer, or, now it's all Rust, right? If you're doing embedded, you got to do Rust. Well, Rust is fun. I love the language. But if you're a .NET developer, you don't need to go all the way down into those depths. You can still do, 95% of this development.
This totally redefines the term of the, quote, full stack developer.
Oh, yes. Yeah, it's full stack all the way down to the registers.
That's right. Oh, full stack. Well, let's talk about that full stack. Wow. Okay. So, what can people use today?
Today, for Meadow Linux, all of the discrete I/O, so digital in and outs, work. Interrupts, so getting events like when something changes from low to high, high to low, that does not work. It's on my list of things. It's just one of those, I know how to do it, so it's not all that interesting to solve. I2C works, SPI works. Those are two communication buses, and those open up, just through Meadow Foundation, something like 130 peripheral drivers. So we've got 130 peripherals, everything from GPS to, temperature and 9 degree of freedom, attitude sensors, all of that stuff works. So a very large amount of what you might want to do will work. The notable things that aren't working is right now we don't have PWMs working. So that's basically a pulse width modulation, which gives you an analog output through a differential width square wave. The A to Ds, so analog to digital, is not working, but the primary reason for that is the only thing that I've found that has A to Ds on board is the Meadow F7, right? The Raspberry Pis and things like that don't have A to Ds, though they have peripheral hats that have A to Ds, but you usually talk to those over SPI or I2C. So we've got it covered, right?
Gotcha.
There are probably some other, there are some other edge case things like the power management. How do I, go into sleep and things like that? I've not done those for Meadow for Linux yet, but they'll come. I'm just trying to get the core functionality first, and then we'll build up those niceties, because they will be fairly easy to do, but they're going to be very, very platform specific. How do you, put a Raspberry Pi to sleep is different than a Jetson, is different than a NUC, is different than everything, right?
Yeah. Now, maybe this is too off topic, but does this, or how much does this bleed into robotics?
Bleeds into it very well. I've got a robotic vehicle sitting here right next to me that I've been building, and it's got a Jetson Xavier on it. It drives motors. It's got a motor controller. It's got it's got the both RC control, but also autonomous behavior as well. And it has something like 6 sensors on it. I was adding another one today. Some LEDs for being able to give you a visual status of its tilt. And all of the sensors that are running on it are running Meadow Linux.
Nice. Man, the possibilities are just running through my head. It's like anything, you can control, get data from any sensor and then control any motor, any servo. I mean, what can't you do at that point?
The only thing you can't do is something that requires real-time deterministic behavior. So you can't do like motion control where I need something to go a specific amount of time or a specific, number of counts down in the nanoseconds and milliseconds range. .NET just is not good for that. It's never been good for that.
Mm-hmm.
So you can't do that. I would not do a safety critical situation with it either, where, somebody hits an e-stop and a big arm needs to stop instantly so it doesn't kill someone. I'd probably avoid those scenarios. But, if it doesn't require real time, I think it's fair game. And even if it requires real time, most things that require real time it's a small subsystem. Mm-hmm. Of just this little area requires real time, but all of this other, sensor data and things, those often don't require it. So you could have the real time system communicated with network or serial or whatever as effectively a coprocessor running with this anyway.
Nice. Wow. All right. I'm excited. This is good stuff. So many possibilities. So you mentioned a test framework. You mentioned plans for a Raspberry Pi build server. With all your stuff you're doing now, what is your DevOps chain? Are you using any commercial products out there, or is it just you got to build all of it yourself?
Most of, at least the foundation is all run in GitHub, right? So we check in and GitHub Actions, do a bunch of builds. Once that has happened, then the goal, it's not fully working right now, but the goal is to have Test Suite pull the binaries down to the local machine, Raspberry Pi or Jetson or whatever, run those tests, and then report back probably maybe even to GitHub what the results are. So GitHub is where, a vast majority of, checking, make sure all the code's there, make sure that some unit tests for the code pass, make sure all that happens. Once that has happened, then it goes off board and it's all, Wilderness Lab specific. I'd say it's proprietary because we wrote it, but it is all still open source. So,
yeah. Okay. And just to confirm, I know Microsoft App Center is used a lot for smartphone and mobile app development. Does that have you seen that have any intersection with embedded?
I have not seen any intersection with it at all, no. Okay.
Sounds like this space has a lot of maturing to do just from a supported products perspective of building, testing, promoting code.
Ton of stuff to be done. And the amazing thing is, the number of IoT devices that exist and that are coming online every day, it's staggering numbers. And as people get better at it and as more tools, come around, so people say, oh, I'm a .NET developer, I can start making edge devices. Well, that's going to actually lead to more of the problem of we have more people building things now. We need these back end assets to test these. So I'm hopeful. We're going to have lots of people starting to play with it, starting to work on it, and they're going to have the same needs. And, we as a community will build this stuff out.
Yeah. Awesome. Well, Chris, thank you so much for coming on the Azure DevOps podcast and sharing all this. This is really exciting. And the listeners are chomping at the bit to go not only grab a new Meadow board, but also check all this stuff out and see what they can get working. So thanks so much for coming on the show.
Absolutely. Thanks for having me.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.